Hello, hello, hello. Welcome to 7.6. We are going to be factoring completely and then solving by factoring. So there are two components to this lesson, and the first of which we're going to work through kind of a process of factoring. And the second, we are going to take that to kind of the next step, which is then solving by factoring. So we've been factoring expressions, and now we're going to move into factoring equations. To start out here, just a little reminder, there are three types of polynomials we are going to be working with. We are going to have two-term polynomials, which we call binomials. We are going to have three-term polynomials, which we call trinomials, and then four-term polynomials, which we just call polynomials. Each one has its own kind of process that we're going to work through, and we have practiced this already leading into this lesson. So if you have any questions about what a binomial, trinomial, or a four-term polynomial is, please look back at our previous videos. Factoring, though, so this is going to be what we're working with. Factoring is the process of breaking down a polynomial to find what groups of terms can be multiplied to create the given expression. So we're going to be working with an expression, and just like we've done in the last several lessons, we're going to be working back to find what multiplied to make those numbers. So off to the side here, you don't have to write this down, but I'm just going to give you a little example. Think about the number 24. So for 24, if I were to try and break that down into the numbers that multiplied to make it, we could use 2 and 12, but we could also think of like 3 and 8. We may also think, 4 times 6. So there are several different numbers that multiply up to make 24. Think about the number 6. So the number 6, we have 2 times 3. And that's really the only combination we have outside of 1 in the number. So we've been working with breaking down polynomials into the two things that multiplied to make them what they are. Now we're going to start working with polynomials that break down. So for example, we may get 4 times 6, but then we can break it down further, 2 times 2 and 2 times 3. So that's kind of the next step. When we talk about factoring completely, we talk about, like, we've learned how to do this, 6 into 2 times 3. Now we're kind of taking that idea, but we're finding it inside of something larger. So hopefully this will make sense at the end. But when we're factoring completely, so far we've been practicing each skill independently. So again, that's two-term binomials, three-term trinomials, and four-term polynomials. You may remember we had difference of two squares, we had using the x factor, and we have using factoring by grouping or the box. So we've been doing those independently. Now when we factor completely, we're going to begin to look for these patterns and opportunities for polynomials to be factored all the way down to their simplest form. Just like we can take 24 and not only break it into 4 times 6, but then break it into 2 times 2 times 2 times 3. So I've created this flow chart. And in this flow chart, this is kind of the process that we're going to follow for factoring. The first line of defense before we even do anything is we always want to look for a greatest common factor. So we're going to look at our terms and we're going to say, hey, is there anything in common that we could divide out of everything? And we want to keep that with our work as we work through, but we're always looking for greatest common factor first. And I've given us lots of examples that have greatest common factors so that you can see it plenty of times. The next thing that we really want to look for or identify and I didn't know how to do this in the document or in the thing that I used to create the notes, right? Like creating these arrows. But we now want to look for, are there 2 terms, 3 terms, or 4 terms? And I've tried to color coordinate this. So once you identify if there's a greatest common factor and you factor that out, then you're going to look for, are there 2 terms, 3 terms, or 4 terms? If there are 2 terms, then we're going to try to do the difference of 2 squares. If you can't do the difference of 2 squares, then it may already be just factored down as far as it can go. If there are 3 terms, we are going to look to see if there's a leading coefficient. Remember, that's a number in front. If you need a refresher, you need to go back and watch some of our previous lessons. But no leading coefficient, no number in front. You're going to fill out your X factor and then use the side numbers to create groups. You'll see what that looks like. Or you will have a leading coefficient. If there's no leading coefficient, there's no extra work. You fill out the X factor, you get your side numbers, and you make groups out of those side numbers. If you have a leading coefficient, then there is extra work. So if there is a number in front, there is extra work to do. You fill out the X factor, and then you're going to use those side numbers to factor by grouping, to use the box method, or to use bottoms up in order to create groups. Again, if those 3 words are foreign to you, then you need to go back and watch some of the other videos on how to do this. The last thing is if there's 4 terms. If there's 4 terms, you're going to want to factor by grouping or use the box method. And then once you've completed, so again, this is a flow chart. So you do this. Once you've completed, you're going to always check to see if there is more factoring that you can do. So once you've done this, you go back up and then you're going to check to see if there's more that you can do. So I'm going to try and show you, following this flow chart the best that I can, kind of what that would look like. So let's jump into the first one. The first one, we're going to look for greatest common factor. In example A, between 50 and 18, we want to know, is there a greatest common factor? I always take my smallest number and I can list my factors. So I have 1 and 18, 2 and 9, 3 and 6. And I want to know what's the largest of that group of numbers that will go into all of my terms. So 18, what I'm going to do is I'm going to take 50 and I'm going to divide it by 18, and that gets me a decimal. It gets me 2.7. So 18 doesn't work. And you may be able to do this in your head. I'm going to talk you through. 50 divided by 9 gives me 5.55 repeating, no good. 50 divided by 6 gives me 8.33 repeating, no good. 50 divided by 3 gives me 16.6 repeating, no good. 50 divided by 2 gives me 25. No decimal. So this is my greatest common factor. So what that means is that out of both 50 and 18, I can divide out a 2. I'm also going to look at my variables. I have x to the 8th and x to the 2nd. The most amount of x's that I can pull out of both of these groups, that both groups have to give, is x to the 2nd. So 2x to the 2nd is our greatest common factor. So again, remember, we're always looking for that greatest common factor first. That's our first line of defense. So I'm going to divide that out, and then I'm going to write what's left over. So 50 divided by 2 is 25. X to the 8th divided by x to the 2nd leaves me with x to the 6th. And minus 18 divided by 2 is 9. And x to the 2nd divided by x to the 2nd leaves us with no x's left over. So I'm not going to write any x's here. Okay, so the next thing I'm doing, I found my greatest common factor. Now I'm going to look to see, are there 2 terms, 3 terms, or 4 terms? So when I look at this, I'm looking inside of my parentheses and I'm saying, oh, there are 2 terms left over. After I found my greatest common factor, there are 2 terms left over. So I want to see, is there a pattern? Is there a difference of 2 squares? And when I look at this, there is a pattern. I have a perfect square. As long as you have an even exponent, that's going to be a perfect square. And 9 is also a perfect square. So here's what I'm going to do. I can't forget about my 2x squared. Remember when I talked about breaking down 24? 24, if I use 4 and 6, then if I break 6 down further, I still can't forget about my 4. That was still used. Or if I broke 4 down, I still couldn't forget to break down 6. So I have to break everything down, and everything that I pulled out is still part of like kind of what's going on. So my 2x squared gets rewritten. That's multiplying. And now we're doing our special pattern, our difference of squares. So I'm going to find the square root of 25, which is 5. The square root of x to the 6th. When we take the square root, we're just going to divide by 2. So 6 cut in half, 6 divided by 2 is 3. And then the square root of 9 is also 3. And then remember, I do 2 sets, and I make 1 positive and 1 negative. So I did my difference of 2 squares. The last thing I'm going to do is check to make sure there's no more factoring. So I'm going to look at my groups and I'm going to say, can I factor these? Are there difference of 2 squares within these answers? And in this case, there's not, because I don't have perfect squares all the way across. And there has to be subtraction. So this would be the final answer. Just like we broke down 24 into 2 times 2 times 2 times 3, we can break 50x to the 8th minus 18x to the 2nd into 2x squared times 5x to the 3rd plus 3 times 5x to the 3rd minus 3. If I were to go through and like multiply this out, get numbers, and then double distribute and multiply that out with this, I would get back to this answer. So all we're doing is breaking this down. Okay, so let's take a look at example B. In example B, our smallest number is a -3. So what I'm looking to see for a common factor is, can I pull a -3 out of all of these? And I'm saying negative because whatever the sign is in the leading coefficient, whatever our front sign is the sign that we want to use when we're pulling out our greatest common factor. So if it's positive, like it was in A, this was positive, so I used a positive. If I have a negative in front, I want to factor out a negative, even if that's just a 1. And so I want to say, can 15 be divided by 3? That's a yes. Can 108 be divided by 3? That's also a yes. So -3 is our greatest common factor. I'm going to look, do I have an x that I can take from all 3? Do I have a variable that can be pulled from all 3 terms? And the answer is no. I have a variable here and here, but 108 doesn't have a variable to give, so I can't pull a variable. So -3 is our only greatest common factor. And then we're going to divide and see what's left over. So when I divide by a negative, it's going to flip my sign. I could do all that work right now. This is going to give me positive, negative, negative. Now let's go through and just divide our numbers. So 3 divided by 3 is 1. So that's going to be 1x squared. 15 divided by 3 is 5. So it's going to be 5x. And 108 divided by 3 is going to give me 36. And I already followed my sign rules to figure out what my signs would be. Now I don't necessarily need a plus out there. Okay, so greatest common factor, done. Now I'm going to look, 2 terms, 3 terms, or 4 terms. So here I have 3 terms inside here. So 3 terms, I'm going to look, do I have no leading coefficient or I have a leading coefficient? Well, here I had a leading coefficient, but I'm looking at this piece after I've done my greatest common factor. And in this piece, I do not have a leading coefficient, or I have a leading coefficient of 1. So I'm going to fill out my x factor and use my side numbers to create groups. So check this out. We're almost just ignoring this. I mean, it needs to be written back in our answer, but we're just using this as if it's its own thing. So I'm going to put negative 36 on top, negative 5 on the bottom. I'm looking for what will multiply to make 36 and combine to make negative 5. What will multiply to make negative 36, combine to make negative 5? That should be a negative 9 and a positive 4. Negative 9 times 4 is negative 36. Negative 9 plus 4 is negative 5. No leading coefficient, no extra work. I take my two terms and they get written down with my variable. So I get x minus 9, x plus 4. Again, if how I got to here is confusing, please go back, watch some of our other videos that show you how we factor this, because we're taking the pieces we've already learned about and now we're putting them together. Okay, and then the last step, I'm going to check to see if there's any more factoring. So I have two terms here, so I'm looking for difference of squares. X is not a perfect square. 9 is, and it's subtracting, but x is not a perfect square. This would need to be x squared for me to break that down. X plus 4, plus sign, not difference of squares, dead giveaway. So this is our final answer. Thank you for hanging with me. I know these notes are kind of long and there's a lot going on, but hopefully this explains it in such a way that it makes sense to you, because this is a difficult concept, and I acknowledge it's even more difficult to learn online and just through a video, through me talking at you and not working at your side. Okay, so greatest common factor, we're looking for variable and number. So for numbers, I have a 2, a 34, and a 140. 2 is my smallest number, so I want to make sure, can 2 go into 34? Can 2 go into 140? They're all even, so 2 is a common factor. And then I'm looking for what's the least or the greatest common variable that I can pull from all three of these. So this has 4 x's, this has 3, and this has 2. So every single one of these can give 2 x's. If I take any more than that, this one doesn't have enough to give. So I can take an x squared out. Now I'm going to go through and divide these. So 2 divided by 2 is 1. X to the fourth and x to the second. We subtract to get x to the second. And we really don't need to write the 1. Negative 34 divided by 2 should give us negative 17. And x to the third minus x to the second. Oops. Is going to give us x to the first. And then 140 divided by 2. It's going to give us 70. And x2 and divided by x2 is going to leave us with no x's here. So now I'm going to look on the inside. Do I have 1, 2, or 3 terms? This is 3 terms. So I'm going to say, do I have a leading coefficient? I do not. So then I'm just doing my x factor. Last term goes on top. It's really first times last to go on top, but first times last is 1 times 70, so it's still just 70. Negative 17. What will multiply to make positive 70 and combine to make negative 17? That's going to be a negative 10 and times negative 7. Negative 10 times negative 7. No number, no extra work. So we can say this is x minus 10, x minus 7. And then this 2x squared is still a part of it. Because if I just multiplied these up, it would only make this. I need this 2x squared to help me get back to our original. Okay, and then example D. We're looking for greatest common factor. There is no greatest common factor between these. I would need a variable here, which I don't have, and I would need a number over here, which I don't have. So then my next pattern I'm looking for, 1, 2, or 3 terms. This has 2 terms. That means I'm going to be looking for difference of squares. I do have perfect squares. Check this out. This one's going to be kind of a long one, so just hang with me. The square root of 16 is 4. The square root of x to the 8th is just half of that. So half of x to the 8th is x to the 4th. And then remember, with difference of squares, we create two sets. One that's positive, one that's negative. My next thing to do, after I've done difference of two squares, I want to check for more factoring in the groups. So I'm going to look here. This one I can't factor any further because it has a plus. So even though it's a group of 2, it has that plus. Even though these are perfect squares, this plus sign doesn't let me factor it. But I have perfect square, and it's subtracting. So in blue here, I can break this down even further. Square root of 4 is 2. Square root of x squared, or of x to the 4th is x squared. And I can create two sets of that. Oops. Used to having the variable in front. And then one is plus and one is minus. This guy didn't change, but he's still multiplying with everybody. And this would be our final answer. So when we're talking about factoring completely, we're always looking for the greatest common factor. Then we're saying, are there 2 terms, 3 terms, or 4 terms? And we're following our steps that we've already been practicing to factor 2 terms, 3 terms with no leading coefficient, 3 terms with a leading coefficient, or 4 terms factored by grouping. And then always at the end, we're looking for more factoring in the groups. For the most part, for factoring completely, you're going to see 2 and 3 terms, the most. 4 terms will show up, but not often.